we have learned how to solve quadratic equations by factoring, and in the next unit we'll learn how to use radicals to solve other kinds of quadratic equations. But every once in a while you'll find a quadratic equation that cannot be solved by factoring. In that case, we have what is called the quadratic formula to help us. To use the quadratic formula, and you can actually use it on any quadratic equation, your equation must be in standard form ax squared plus bx plus c. And when you have it in this form, you can use the quadratic equation, which is the opposite of b plus or minus the square root of b squared minus 4 times a times c, the entire thing divided by 2 times a. Let's look at some examples on how we would use this. In this equation, we have to first say, hey, is it in standard form? Remember, it has to be ax squared plus bx plus c, and when I'm looking at this equation, it looks as if it is. So the next thing I'm going to do is I'm going to identify my a, my b, and my c. And I've written down our quadratic equation, so it's easy to use here. Our a in our equation is 1, our b is 7, and our c is -2. Notice that I wrote the -2 in parentheses, and that's super important to do that. Now, the first thing in our quadratic equation is the opposite of b. Our b is 7, so the opposite of b is -7. Then it's going to be plus or minus the square root of b squared, so that would be 7 squared, minus 4 times a, our a is 1, times c, and our c is -2, all over 2 times a, which is 1. Now, I am going to simplify what is underneath the radical. So I'm going to take this string of numbers and I'm going to put it in my calculator without the radical symbol. And I'm going to get 57. So this is -7 plus or minus the square root of 57 divided by, the whole thing divided by 2. The next thing I would do is factor out any perfect square from the radical. Well, 57 does not factor into any perfect squares. Actually, the only factors of 57 are 3 and 19, neither of which are perfect squares, so I don't have to worry about that. So as strange as it may seem, this is the answer to my quadratic equation in exact form. Math Excel will often ask you to answer in exact form using radicals as needed. Sometimes it will ask you to separate your answers by a comma. In that case, here's what you would write. -7 plus square root of 57, the entire thing divided by 2, comma, -7 minus square root of 57, the whole thing divided by 2. Because remember, you can have up to 2 solutions to a quadratic equation. Now, sometimes, rarely, but sometimes, they will ask for the answer as a rounded decimal. And in that case, usually they ask you to round 100. So let's answer this as a decimal rounded to hundredths. I would take -7 plus square root of 57, the whole quantity divided by 2, and enter it in my calculator. And I'm going to get a long run-on decimal, which I would round to 0.27. Then I would enter in my calculator -7 minus the square root of 57, the whole quantity divided by 2, and I'm going to get -7.27 when I round the long run-on decimal it will give me. I would like you to try entering both of those things in your calculator to make sure you get the same decimal that I did. If you did not, it's probably how you're entering it, and you need to come see one of us as your teachers, and we'll help you with that. Let's look at another example. When I'm looking at this quadratic equation, remember it has to be in standard form, and this one is not. So that's the very first thing I'm going to do is subtract 6x and add 1 to both sides of this equation to get the equation in standard form, 3x squared minus 6x plus 1. Then I'm going to identify my a, my b, and my c. My a is 3, my b is -6, Notice that I've put this in parentheses, super important, and my c is 1. Here's our quadratic equation that we can use, and now we're going to enter our numbers into this equation. Our b is negative 6, so the opposite of negative 6 is a positive 6, plus or minus the square root of b squared, or negative 6 squared. Notice that I put it in parentheses, and if you do not put it in parentheses, you will not get the correct answer here. Minus 4 times my a, which is 3, times my c, which is 1, the entire expression over divided by 2 times a, which is 3. Now I'm going to simplify what is underneath the radical. I'm going to put in my calculator, using parentheses, this expression. And when I do, I'm going to get 24. So now I've got 6 plus or minus the square root of 24, all divided by 6. Now, the next thing I'm going to do is factor out any perfect squares from underneath the radical. Well, 24 can be square root of 24 can be factored into the square root of 6 times the square root of 4. And square root of 4 is indeed a perfect square, which equals 2. So I'm going to rewrite the square root of 24 into 2 times the square root of 6, all over 6. Then the last thing is to reduce any whole numbers that can be reduced. So I've got whole numbers of 6, 2, and 6. I'm not looking at my number underneath the radical, and those could all be reduced by 2. So that would give me 3 plus or minus 1 square root of 6, and I'm just going to write down the square root of 6, all over 3. And this is my answer in exact form. The last example that we're going to look at is already in standard form, so I'm just going to identify my A, my B, and my C. My A is 2, my B is 4, my C is 7. My B is 4, so the opposite of B would be negative 4, plus or minus the square root of 4 squared minus 4 times my A, which is 2, times my C, which is 7, all divided by 2 times my A, which is 2. Then I'm going to simplify what is underneath the radical. So I'm going to say negative 4 plus or minus the square root of negative 40 all over 4. Now, if you put square root of negative 40 in your calculator, it's going to give you an error because you cannot take the square root of a negative number. That is not a real number. So when you get this situation, what this means is that there is no solution to this quadratic equation. All right, I think that you probably have enough that you can get your practice started.